welcome back, my learner, my student, wherever you are. So, it's another humble time we want to make our life easy. Today, I'm going to look at a topic in chemistry from 4. The last topic in chemistry from 4, that is radioactivity. It is an easy topic, but difficult to some of you learners. But it is a topic that can make you go places in this life. So radioactivity is the last topic in Form 4. I will tackle it in summary for better understanding. So welcome and follow me so that we understand what we really mean by radioactivity. So the term radioactivity, we will start by defining the term radioactivity. What do we mean by radioactivity? So radioactivity is the process where unstable nuclide break to yield another nuclide of different composition. That is radioactivity. In short, we can say that radioactivity is the spontaneous disintegration or decaying of unstable nuclide. It's simply the decomposition of a nuclide. So what do we mean by a nuclide? That is our second thing. A nuclide is an atom defined by mass number, atomic number, and definite energy. What do we mean by mass number? For example, when we are given this element here, we can say it is helium. You can say this element is helium. This 4 represents our mass number, and mass number is the total of protons and neutrons. This 2 represents the atomic number. This 2 represents the atomic number, which is the same as the number of protons. And this is our element helium. So to find the number of neutrons, you take this 4 minus 2. Another simple example, when you are given maybe calcium, let us say 18 and 7. This 18 is our mass number, this 7 is an atomic number or the number of protons. So to get the number of neutrons, we will take the mass number, which is 18 minus 7. So we have 9. 18 minus 7, we have 11 neutrons. So that is basically what we mean by a nuclide. So next we want to look at what is the difference between a stable nuclide and unstable nuclide. That is our next thing we want to look at, a stable nuclide and unstable nuclide. And we have said the one that decays should be unstable. It's the one that decays to give us so we can look at examples. The first example of identify whether stable or unstable. We can have oxygen, that is, it has 16 and 8, and we can also have chlorine, let us say 38 and 17. So we are looking at a stable nuclide has the same number of protons and neutrons. So this oxygen has how many protons? This one here, 8. It has how many neutrons? You take 16 minus 8, you get 8. So when you take protons all over neutrons, you get 1. This means that the number of protons and the number of neutrons is the same. So this oxygen here is a stable nuclide. So it will not undergo decomposition or radioactivity. What about this example here, chlorine? We said that chlorine has an example, it's not the real one, 38 and 17. So our mass number is 38. So the number of protons here, this one, the atomic number, is 17. What about neutrons? You take 38 minus 17. What do you get here? 38 minus 17, that is almost 21. So when you look here, protons 17, neutrons 21. So this one is unstable because the number of neutrons is not equal to the number of protons. So that is simply knowing the difference between a stable nuclide and unstable nuclide. So this unstable nuclide undergoes some disintegration or decomposition, which is radioactivity, to form another element. another element. So let us move on and see. It undergoes through three types of rays. That is the alpha, the beta, and the gamma. So we'll start with the alpha particle. We have said that unstable nuclide disintegrates by emitting rays, and these rays are classified into three. We have the alpha particle. It is symbol alpha particle. This is its symbol we shall be using. That is the first one. The second one is beta, the beta particle, and finally the last one will be gamma. So we're going to look at this one by one. These are the rays emitted for decomposition of unstable nuclide. So we shall start with the alpha particle. One on one, quickly, the alpha particle. So what do we mean by alpha particle? These are some of the features of the alpha particle. So the alpha particle, firstly, it is positively charged. And another second feature, which is a constant one, its mass number is 4 and its atomic number is 2. So when we look at the periodic table, an element with mass number 4 and atomic number 2 is helium. So an unstable nuclide undergoes disintegration of alpha particle, that is helium, to form another one. And positively charged, mass number 4, atomic number 2, it has a low penetrating power. Low penetrating power means that it can easily be stopped by a piece of paper. The rays can easily be stopped by a thin piece of paper. So having low penetrating power means that it has high ionizing power. What is now its effect? A nuclide undergoing the alpha decay has its mass number reduced by 4 and atomic number reduced by 2. Why are we saying reduced by 2? Because we have to say that they are positively charged. So the positively charged, it gives a decrease in the mass number and atomic number. We can look at an illustration or example. So we can look at this element. Make sure you zoom the see clearly. This element 241, 95. It is undergoing now alpha integration. This one. So, which element will now be formed? We have said a nuclide undergoing alpha decay has the mass number reduced by 4. So this one is our mass number 241. So it will be reduced by 4. So you take 241 minus 4, you will get 237. And atomic number reduced by 2. So this is 95. When you reduce it by 2, you will get 93. And this a new element will be formed. So for those who don't understand the symbols, this Am is for amalcalium, and this one Np is for Neptunian. So these two, this one has integrated to form this one. So this is the effect. This is the alpha particle bringing its effect. At the end of the day, when we take 4 plus 237, we get 241. 2 plus this one, we get that one. We can look at another example. We can be given radium, that is 222, can be given radium. This one is 88, radium. It undergoes this alpha decay. So when it undergoes alpha decay, which new element will be formed? So this one is our new element formed. This one has decayed to form this one. So which new element will be formed? You come at the mass number 222, mass number reduced by 4. So 222 minus 4, that is 218. And atomic number reduced by 2, that is 86. and a new element will be formed, that is Rn. When you look at the on the periodic table, element number 86, it is simple, is Rn. So that is all about the alpha particle. Easy like that. We move one on one up to the beta particle. Let us correct the spelling. The beta particle, that is number 2. Beta particle. Beta particle, it is simple. It's this one. It's not too hard. The features now. The first feature, it is negatively charged. Remember, the alpha one was positively charged. Then the second one, no mass number and atomic number. This one has no mass number. Remember, the alpha particle had mass number 4, atomic number 2. But the beta particle, no mass number, but the atomic number is -1. We can simply say that it represents the electron, they are negatively charged. Then the beta particle have medium penetrating power. Also have the medium ionizing power. We have said the alpha has low penetrating power and high ionizing power, but the beta has both of them medium. So alpha particle has low penetrating power, which means it can be stopped by a thin piece of paper, the alpha particle. But now the beta particle has a medium penetrating power. We can also say that it can be stopped by a piece of aluminium foil. The rays can be stopped by a piece of aluminium foil. The effect now, a nuclide undergoing the decay has its mass number remaining constant and atomic number increased by 1. Why do we increase by 1? It is negatively charged, and the negative here is -1. So the atomic number will be increased by 1 and mass number remaining constant. We can look at an example, at least one. And look at least one example. An element, so say for example, an element N having 13 and 7, it undergoes the beta particle. We have said the mass number is 0, atomic number -1, is negatively charged. Which new element will be formed now? Which new element will be formed? We come at the mass number. Mass number will remain constant, so it will remain 13. What about the atomic number? What about the atomic number? Atomic number will be oxygen when we look at the periodic table, because it was 13. Mass number remained constant, so 13, we get 13. Then 7, the atomic number is increased by 1. 7 plus 1, 8. But when you are keen, when you look at our initial element, when you calculate the number of protons in this element is 7. What about the number of neutrons? That is 13 minus 7, we get 8. What about our new element? The number of protons and the number of neutrons. Protons, how many are they? 8. What about neutrons? Neutrons, we take 13 minus 8, that is 7. So this 8, which is the number of neutrons, this is 7, the number of neutrons. We have here that the number of protons was 7, was converted to neutrons. The number of neutrons in our new element is 7. We can guess another example. We can say our element B. Our element B, can give it 16 and 9. So it undergoes a beta reaction, that is -1. So what will be our new element? It will be 16, then 9. We have said the atomic number is increased by 1. This one will be 10, and the new element can be, let us say, Q. So we realize that this one was the number of protons. This was the number of protons. The number of neutrons here was 16 minus 9, that is 7. This one is 16 minus 10. This 10 is the number of protons. What about the neutrons here? Protons are 10. The neutron will be 16 minus 10, which is 6. What about here? Here we can look at the number of protons is 9. What about the neutrons? Will be oxygen when we look at the periodic table, because it was 13, mass number remained constant, so 13, we get 13. Then 7, the atomic number is increased by 1. 7 plus 1, 8. But when you are keen, when you look at our initial element, when you calculate the number of protons in this element is 7. What about the number of neutrons? That is 13 minus 7, we get 8. What about our new element? The number of protons and the number of neutrons. Protons, how many are they? 8. What about neutrons? Neutrons, we take 13 minus 8, that is 7. So this 8, which is the number of neutrons, this is 7, the number of neutrons. We have realized that the number of protons was 7, was converted to neutrons. The number of neutrons in our new element is 7. We can guess another example. We can say our element, our ray number 3, the gamma particle. The first one was the alpha particle, positively charged. Second one was the beta particle. These are the symbols, negatively charged. And now the third one is the gamma particle. Its symbol is Y. So what are the features of this gamma particle? It is neutral. It is not neither positive or negatively charged. Beta, the alpha was positive, the beta was negative, and the Y particle is not negative or positive. We can use not. So this one is neutral. This one is neutral. The second one, it has a high penetrating power. It has a high penetrating power. High penetrating power, we can also add, it can be stopped. It can be stopped by a thick lead metal. A piece of thick lead metal. The alpha particle has a low penetrating power. Alpha particle, low penetrating power. It can be stopped by a piece of paper. The beta particle has a medium penetrating power. It can be stopped by aluminium foil. The Y, or the gamma particle, the Y ray, has a high penetrating power, and it can only be stopped by a thick piece of lead. Then it has low ionizing power. Now here, simpler. When it has high penetrating power, automatically low ionizing power. But when it has a low penetrating power, it will be high ionizing power. Then it has no mass number and no atomic number. It has neither a mass number or atomic number. So the mass number and the atomic number of a nuclide undergoing the Y decay remains the same. Why is it remaining the same? This one is neutral, so it has no effect. Then we have said that it has no mass number or atomic number. So as we wind up, we can come for a short illustration here. So when these three rays are released at the same time, when we release the beta, this one is the beta, the alpha. When we release the alpha particle, it will be stopped by a piece of paper. It will be stopped here. It will not manage to pass. But now the second one, the beta particle will manage to pass this piece of paper, but it will stop on aluminium foil, because it has a medium penetrating power. This one has low penetrating power. But now we have the third one, which has very high. This is the gamma particle, high penetrating power. It will be managed to be stopped by what we call lead metal, and a thick one. So that is all we have to know about the rays, the alpha, the beta, and the gamma. So next we shall be looking at now the real reductive action. We shall be looking at what we call the half-life. At what time is taken for this to be converted to this one, the half-lives. So subscribe, share, you can leave a comment. Anywhere you don't understand, you can just leave a comment there. Any question that you feel like it has a challenge, you can send it to my email. I'll place it below the video link. So welcome to my next lesson, that is reductive elements.